Here we go. Question number 16. Suppose A and B are two non-zero real numbers such that the equation square root of 3a cos x plus 2b sin x equals 8, where x is defined with the closed interval minus pi by 2 to pi by 2, and the equation has two distinct real roots alpha and beta with alpha plus beta equals pi by 3. Calculate the values of a and b. So this is the question. A different version of the same question appeared in IIT-JEE entrance exam, but I have spiced it up a bit to make it a little more interesting. I would make this question a level 2 question. Let's get into the solution. Let's look at the question a little more carefully. It says the roots alpha and beta are two distinct real roots. That means alpha and beta are not equal, and alpha plus beta equals pi by 3. So there's a lot of giveaways in the question because you have square root of 3, you have 2 in the question, and it is given alpha plus beta equals pi by 3. So you suspect the involvement of sine pi by 6 or sine pi by 3 or cos pi by 6 or cos pi by 3 in the question. And in order to solve this, we need the following toolkits. I'm going to use the product or rather sum to product formula, that is cos A plus cos B, cos A minus cos B, sin A plus sin B, and sin A minus sin B. And also I'm going to use the values of cos pi by 6 and sin pi by 6. And our usual bread and butter Pythagorean identity, that is cos square theta plus sin square theta equals 1. Let's get straight into the solution. Let's write what is given. Given square root of 3a cos x plus 2b sin x equals 8. Let me call this as equation 1. This is our reference equation. Next, what I'm going to do is I'm going to substitute alpha and beta in place of x in the equation 1. Why? Because alpha and beta are the roots of the equation. Simple, right? So I get two sets of equations, and I'm going to solve the two sets of equations like we solve a simultaneous equation to get our final answer. Let's do it. Substituting alpha and beta in place of x. First, let's substitute alpha for x. So you get 0 square root of 3a cos alpha plus 2b sin alpha equals 8. Let me call this as equation 2. Next, I'm going to substitute beta in place of x. So you get square root of 3. So you get square root of 3a cos beta plus 2b sin beta equals 8. Let me call this as equation 3. Okay, now first I'm going to add 2 plus 3. I'll get a neat expression. Then I'll subtract 3 from, rather 2 minus 3. I'll get another expression and solve these two expressions for our a and b. First, let us add 2 plus 3. So let's add 2 plus 3. When you add 2 plus 3, you have square root of 3a as a common term in the first part of the expression. Then you have 2b as the common term, the second part of the expression. So I can factor out square root of 3a from the first part and 2b the second part and write the equation as square root of 3a, open a bracket, cos alpha plus cos beta. Cos alpha plus cos beta plus factor out 2b. Sin alpha plus sin beta. And on the RHS we have 8 plus 8 equals 16. Next, we have cos alpha plus cos beta, right? So I'm going to use the identity cos A plus cos B, which is 2 cos A plus B by 2, cos A minus B by 2. and the second part of the expression has sine alpha plus sine beta. So I'm going to use sine alpha or rather sine a plus b equals 2 sine a plus b by 2 cos a minus b by 2. Okay, let me substitute these identities in the equation here and see what we get. So we have square root of 3a, open a large bracket, cos alpha plus cos beta. Let's write carefully. 2 cos alpha plus beta by 2 cos alpha minus beta by 2. Close the bracket, plus 2b, open the bracket. Sine alpha plus sine beta would be 2 sine alpha plus beta by 2 cos alpha minus beta by 2. 2 sine alpha plus beta by 2, then cos alpha minus beta by 2. And of course, in the RHS we have 16. Okay, now we have cos alpha plus beta by 2, sine alpha plus beta by 2. Alpha plus beta equals pi by 3. So alpha plus beta by 2 would be pi by 6. And we already have the value of sine pi by 6 equals 1 half and cos pi by 6 as square root of 3 divided by 2. Let's supply these values here, and if you notice, cos alpha minus beta by 2 is a common term in both the expression, or both parts of the expression. So I'm going to factor out cos alpha minus beta by 2 and supply the value of sine alpha plus beta by 2, that is sine pi by 6, and cos pi by 6 in the above expression. Okay, so you have cos alpha minus beta by 2 and factoring it out. Cos alpha minus beta by 2 is being factored out. Open a very large bracket. So you have square root of 3. Okay. So multiplied by 2. Then cos pi by 6. Cos pi by 6 is square root of 3 by 2. Then plus you have 2b multiplied by 2. Then sine alpha plus beta by 2 sine pi by 6, which is 1 half. And the whole thing equals 16. So we have nice cancellations here. So this 2 gets cancelled, and this 2 and this 2 gets cancelled, and the expression neatly simplifies to cos alpha minus beta by 2 whole multiplied by, you have square root of 3 multiplied by square root of 3, that is 3a, right? 3a plus 2b equals 16. We don't know what is cos alpha minus beta by 2. So we have to calculate this cos alpha minus beta by 2. For that, we are going to do 2 minus 3. Okay? Subtract 3 from 2. Okay, so we will have, see, when you subtract 3 from 2 on the RHS, it will be 8 minus 8. That is 0. And like before, we have square root of 3a as the common term in the first part of the expression, and in the second part of the expression you have 2b as the common term. So it's pretty simple to write. So you have square root of 3a multiplied by, open a bracket, you have cos alpha minus cos beta, okay, plus 2b multiplied by sine alpha minus sine beta, that equals 0, right? Now, I need an expression for cos alpha minus beta and sine alpha minus beta, which I already have. So I'm going to supply cos alpha minus beta as minus 2 sine a plus b by 2 sine a minus b by 2. On the large bracket, so minus 2 sine alpha plus beta by 2, then sine alpha minus beta by 2, close bracket, plus 2b, then the identity for sine A minus sine, that is 2 times cos alpha plus beta by 2 sine alpha minus beta by 2. Of course, on the RHS it is 0. Now, we have everything that is required to solve the problem. We have sine alpha minus beta by 2 as a common term in both the parts of the expression, and we have the sine pi by 6 and cos pi by 6. So that gives square root of 3, or rather, let me take the common term sine alpha minus beta by 2 first. So sine alpha minus beta by 2 is the common term. Open the large bracket. So you have square root of 3a into minus 2 multiplied by sine alpha plus beta by 2 sine pi by 6. Sine pi by 6 is 1 half. So 1 half plus 2b in multiplied by 2 cos alpha plus beta by 2 cos pi by 6 square root of 3 by 2. Square root of 3 by 2 equals 0. Now, I have this cos alpha minus beta by 2 multiplied by 3a plus 2b equals 16. Let me call that as equation number 4. I will require it in the future reference. Okay, now let me simplify this. So we have sine alpha minus beta by 2. First part of the expression. The second one would be, we have cancellations. This 2 gets cancelled. This 2 and this 2 will get cancelled. So we have minus square root of 3a, right? 3a plus 2 square root of 3b equals 0. Now we have two expressions, sine alpha minus beta by 2, that's one expression, and square root of 3a, rather minus square root of 3a plus 2 square root of 3b equals 0. Therefore, either sine alpha minus beta by 2 equals 0, or let me change the order of the terms. 2 square root of 3b minus square root of 3a equals 0. Okay, now sine alpha minus beta by 2 is 0, therefore cos alpha minus beta by 2 will be 1 from our Pythagorean identity. How? You have cos square theta plus sine square theta equal, and in this case sine square theta is 0 because sine alpha minus beta by 2 is 0. So what we are left out with? We are left out with cos square alpha minus beta by 2 equals 1. Therefore, cos alpha minus beta by 2 equals 1. So which implies cos alpha minus beta by 2 equals 1, and 2 square root of 3b equals square root of 3a. We have square root of 3 getting cancelled. 2b equals 8. Okay, let me call this expression as equation number 5. Next, we have the homework. I have to substitute 5 in 4. Substitute 5 into 4. Okay, the first part of equation 4, that is cos alpha minus beta by 2, doesn't bother us because it's 1. So we just have to look at the second part of the expression. So that will give us 1 multiplied by 3a plus 2b equals 16. but A equals 2B. So 3 multiplied by 2B plus 2B equals 16. So 6B plus 2B, that is 8B equals 16. So B equals 16 by 8, that equals 2. B equals 2. Let's come to A. So A would be 2B, right? Equals 2 multiplied by 2 equals 4. So we have a very neat solution for the question, that is A equals 2 and B equals 4. Okay, so let me box my solution, that is A equals 4 and B equals 2. Okay, let's move on to question number 17.